Now members, let us see how we handle these questions still about binomial. We are exploring more examples. So, given a binomial is find n such that the probability of x greater than 1 is equaling to 0.992. Of course, we know this one I'm setting it, of course, you know, and if we have exact equal to x, this is how we write it. Now, from here, that always our binomial it follows n, p. Here you can easily n is equal to this, so it means that our p is going to be equal to 0.8. And if our p is this, it means that our q is going to be 0.q. I think we know how you get 1 minus the probability of success, which was 0.8 from the question if you compare here. Now they are also telling us that the probability of x greater or equal to 1 is equal to 0.992. Of course, in our, we saw that in our previous lessons, this one is the same as 1 minus probability of x equaling to 0. This is 1 minus probability of x equaling to, we say it's going to be equaling to 1 minus this. So, which will be a 0. Equal to 0.992. When I take this side, it will become a positive. Then when I bring this side, it becomes 1 minus 0.992. Now from this formula, I'm going to use this. Now my x is 0. So this will be now n combination. I don't know n. 0 into success power 0 into 0.2 power n minus 0, because our x is 0, it is n. This is 0.008. So now, n combination, n number combination 0 is 1. N number power 0 is also 1. Then here we have 0.2 power n equaling 0.008. What happens there? We introduce natural log both sides. So the introduce natural log, this is going to follow natural log of 0.2 equaling to, using properties of logarithms, this will come here, it's a log. So divide through, so our n will be divided by natural log of 0.2. And so our n here will be 3. That's the answer there. Now here, the probability that a target is hit is 0.3. Find the least number of shots which should be fired if the probability that the target hits at least once is hit at least once is greater than 0.95. State the assumption and assumptions. So here, said our probability is to hit a target. The probability of success here, which is 0.3. Simply that if you don't hit the target, then we shall fail, which will be 0.7. You get 1 minus 0.3, you get the probability of failure. Now, the telling us that the probability of hitting at least once that target is greater than 0.95. So, at least, when you have these cases, this is what the sign will look like. And we have seen this the same as 1 minus probability of x equaling 0.95. So I take this side and bring this side, be 1 minus 0.95, where the probability when x is equaling to 0. So this is going to give us 0.05 greater than. Now I'll put in our formula here. So n combination 0, 0.3 power 0, and 0.7 power n minus 0, which will be that. So this side will have 0.05 greater than 0.57 power n. Introduce natural log both sides. So this n will fall off. So this is the step I skipped here. So this n will fall off and we have now natural 0.05 greater than n natural 0.7. Divide through by this part. When you are dividing, be careful, please. So this will be natural 0.05 over natural 0.7. Now, because when we press natural over 0.7, it's negative. And remember, we said in inequality, if you divide through by negative, the inequality sign changes. Why? Because this one is a negative. You try it. You place natural over 0.7. You start, you are going to get a negative. So the whole of this is negative. So when you divide through, don't forget that the inequality sign will change. From there, what we get is 8.399 than n. So therefore, the next integer above this will be n equaling to 9. Then the integer greater than this. So let us see what happens here. Here, try this. Is there, and that's why this inequality changed. Because we said the inequality, if you divide this by negative quantity, the inequality sign changes. So this, you place natural on 0.7, so it's going to be negative. So that's why this changed. And now this, 5% of the light bulbs in the box are faulted. Using the binomial model, find the largest sample size which can be taken if it's required that the probability there is no faulty bulb is greater than 0.1. So here our probability of success is now the bulb to be faulty. So it's 5%, which will be 0.05. When you divide this 5 with 100, so our probability of failure now will be 1 minus this 0.95. Now they're telling us that the probability that no faulty means that it's 0. It means it's greater than 0.5. As simple as that. This time they don't want any. Now no faulty means that the small x is going to be 0. Because now our probability is to be a faulty value. So now, this is the same as n combination 0 into 0.05 power 0, then 0.95 power n greater than 0.5. This will be 0 and this will be 1. I mean, this will be 1 and this will be 1. So remaining 0.95 power n greater than 0.5. Introduce natural both sides. Those are important. You can introduce law to base 10. It is also very okay. So now this will be natural. Now because this is, whenever you have a value of x between 0 and 1, natural log of x is always going to be less than 0. It's going to be negative. So we divide it by this. Now the inequality, because this is going to be negative, now we change this to this. And so my value here should be 13.5134. Now, here be careful. The number we want should be less than 13. It's not 12. Why? Because you see 13, we have 14 and 13. This one is here. This is our 13.5. So if you want, if it was greater, then the next integer after this will now be 14. But this one is less. So the next integer after this is 13. Copy. Therefore, our n is 13. As simple as that. So here they ask for assumptions. Our assumptions are So in simple terms, they're asking for the properties of a binomial. The properties will say this P should not change. I mean, it should be a constant. Then the other you can give also that the number of trials should be independent. You can also give that, and so on. So those are the such simple terms to give the properties we saw in the first lesson. So that's it, members. I wish you